This question is asking about the specific gravitational field strength. So we can use the formula G equals 4 pi squared L over T squared. A reminder, we've gotten that from rearranging this equation, which is the equation for period of a pendulum, and this one is in your data booklet or on your data sheet. So from here, because we have the length of the pendulum and the period of the pendulum, we can rearrange. And this actually shouldn't say T2, it should say T squared. So T squared. 4 pi squared multiplied by 0.75 meters divided by 1.74 seconds squared, and to get an answer of 9.78 meters per second squared. And we could say that it's meters per second squared, or we could also say that it's 9.78 newtons per kilogram, and either of those answers would be correct. The question is much more difficult. There's a couple steps going on here. So the first thing I've done is I've written down all my variables, and the first thing I have to do is I have to change my amplitude into meters. So I can say that this is 0.1225 meters. I have my Vmax and I have my K. So automatically I would go to my formula to look to find my period. So I know that my period of any sort of simple harmonic oscillator is going to be 2 pi multiplied the square root of m over k. So what you'll notice in this formula is we already have our k, 2 pi we've got, but we don't have our mass. So the first thing we have to do is we have to find our mass. So I'm going to add over here on my variable list that I need to find my mass. Look on our data sheet, you'll notice that we have the formula that is Vmax equals our amplitude multiplied by the square root of k over m. Just a reminder from our past lesson that this formula was derived from the fact that our EP max is going to be equal to our AK max. And that comes from the place that we can say that our EP max is going to be half kx squared and our EK max is going to be half mv squared. And when we rearrange that, we'll get the formula that I just wrote down in blue. So I can take this blue formula and I can rearrange it for m. So what I have to do here is take the square root of both sides. So I'm going to have v squared is going to be a squared multiplied by k divided by m. And if I rearrange this for m, I will get that m is going to equal a squared multiplied by k divided by v squared. I can put in my numbers in order to find my mass. So my a squared is 0.1225 meters. I'm going to square that, multiplied by my k, which is 5.03 Newton meters, divided by my velocity squared, which is 5.13 squared meters per second. I'm going to get my mass is 2.868 times 10 to the negative 3 kilograms. So now I can check over here, I now have my mass. Then my red formula up here at the top, I now have my mass as well. So I'm going to take the mass I just calculated, put it up into my red formula, and that will get me to find my period. Okay, so now all I'm doing is putting my numbers into my red formula. So I have 2 times pi multiplied by the square root of the mass that I just found, 868 times 10 to the negative 3 kilograms, divided by my k, which is 5.03 newtons per meter. And then I am going to get that my period is 0.150 seconds, and that is my final answer.